3-Eye Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
Our solar system has a visitor, and the closer it gets, the stranger it becomes. It's called 3-Eye Atlas, the third interstellar object ever detected, and it's currently hurtling through our cosmic neighborhood at an astonishing 61 kilometers every single second. To put that in perspective, that's over 219,000 kilometers per hour, a speed so immense that it confirms this object is not from around here. It's a true outsider, a messenger from another star system. First spotted in July 2025 by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, it was initially cataloged as just another faint blip. But as astronomers tracked its path, they realized its trajectory was a hyperbola, a path that will swing it once around our sun and then fling it back out into the void, never to return. This is a one-time only show, and with every new batch of pictures, the show gets weirder. This isn't just another rock or ice ball. 3-Eye Atlas is presenting a series of escalating mysteries that are forcing us to question our understanding of comets and even the chemistry of other star systems. A strange green glow, a chemical signature that shouldn't exist in nature, a tail that seems to defy physics, and a size that might be impossibly large. Tonight, we're going to break down each of these anomalies. We'll look at the science behind them, explore the context of our previous interstellar visitors, and look ahead to a critical moment just weeks away when this object will skim past Mars, giving us our best chance yet to unravel its secrets. Before we dive into the bizarre nature of 3-Eye Atlas, it's important to understand why its arrival is such a significant event. It's only the third confirmed object of its kind. Our first visitor, discovered in 2017, was 1-Eye Oumuamua. Oumuamua was a complete enigma. It was small, reddish, and shaped something like a cigar or perhaps a pancake. Most baffling of all, it showed no visible coma or tail, yet it accelerated away from the sun as if something were pushing it. That non-gravitational acceleration remains a profound mystery and has fueled intense scientific debate. Then, in 2019, came 2-Eye Borisov. Borisov was, in many ways, what astronomers had expected an interstellar comet to look like. It had a visible coma and tail and behaved much like the comets from our own Oort cloud. It was a comforting confirmation that comets in other star systems weren't all as strange as Oumuamua. And now we have 3-Eye Atlas. It seems to be a hybrid of the two, as active and cometary as Borisov, but with a growing list of anomalies that make Oumuamua's quirks seem almost tame by comparison. It's a crucial third data point, and it's suggesting that the galaxy is filled with objects far more diverse and strange than we ever imagined.
The first puzzle appeared as a literal change of color. When we first spotted the comet, it had a dull reddish tint. That's pretty much what you'd expect. Comets are essentially dirty snowballs, and the initial color is sunlight bouncing off rock and dust that has been baked and weathered by billions of years of exposure to cosmic radiation. But then, something changed. The latest set of images, shot during the lunar eclipse from Namibia, shows the coma, the vast cloud of gas and dust around the nucleus, has flipped from red to a ghostly, vibrant green. The whole cloud around the nucleus now glows like an emerald. So, what's happening? Cometary color changes aren't unheard of. As a comet nears the sun, its ices sublimate, turning directly from solid to gas and release different molecules. The green glow in most comets comes from diatomic carbon, or C2, a molecule where two carbon atoms are stuck together. When blasted by the sun's ultraviolet light, these molecules fluoresce, emitting a specific green light. But with 3-Eye Atlas, there's a twist. On August 25th, the Very Large Telescope in Chile detected a sudden dramatic jump in the production of cyanide gas. While cyanide can contribute a violet or blue glow, some have theorized it could be part of a chemical mix causing the green color. This leads us to the second, and arguably far stranger, chemical mystery. At the same time it was detecting cyanide, the VLT also found something that has left astronomers baffled: atomic nickel. Finding heavy metals in a comet's coma is rare, but not impossible. The shocker is that they found nickel without any iron tagging along. Down here on Earth, and everywhere else we've looked in the cosmos, pure nickel is almost exclusively an industrial product. In nature, due to the way elements are forged in the hearts of stars and supernova explosions, nickel and iron are cosmic partners. They almost always appear together in meteorites and asteroids. Seeing nickel on its own is, to put it mildly, weird. It hints at a formation environment with chemical rules completely different from our own. As if the color and chemistry weren't strange enough, there's the comet's tail. Or, more accurately, its tails. Most comets have two: a dust tail, which is broad, curved, and scatters sunlight, and an ion or gas tail, which is straighter, glows blue, and points directly away from the sun, pushed by the solar wind. Think of it like a windsock in a cosmic breeze. 3I Atlas has those, but it also has a third, a second, thinner streak of light that points straight toward the sun. This is what's known as an anti-tail, and it seems to defy basic physics. Now, sometimes an anti-tail can be an optical illusion. If Earth passes through the orbital plane of a comet, we see the trail of larger, heavier dust particles that the comet has left along its path edge-on, which can look like a sunward spike. But astronomers studying 3I Atlas believe this is different. They've stated it's not just an illusion created by our viewing angle. The object really is shining sunward. The leading natural explanation is that larger-than-usual ice chunks, perhaps pebble-sized instead of fine grain-sized dust, are cracking off the sun-facing side of the nucleus. These pebbles are too heavy for the solar wind and radiation pressure to easily shove backward. So, they drift forward along the comet's path, scattering sunlight back at us and creating the appearance of a tail growing toward the sun. While it's the best natural explanation so far, we have never seen such a distinct and non-perspectival anti-tail in a comet from our own solar system.
Then there's the question of its size, and the numbers are just as messy as the rest of its features. Estimating the size of a distant object from a single point of light is incredibly difficult. Its brightness depends on two things: how big it is and how reflective its surface is, a property called albedo. A small object covered in bright ice can look just as luminous as a huge object made of dark rock. A typical cometary nucleus, for instance, has an albedo of just 4%, darker than asphalt. Early estimates for 3I Atlas, assuming a typical cometary albedo, placed its nucleus at 3 to 10 kilometers across. That's a respectable size, but not unprecedented. However, a fresh model has been proposed. This model folds in the possibility that the comet's brightness is not coming just from the nucleus, but also from the cloud of icy fragments surrounding it. If the nucleus itself is much darker and less reflective, it would have to be substantially larger to account for the total light we see. This new analysis hints the nucleus could stretch anywhere from 20 to a colossal 46 kilometers in diameter. Let's pause on that for a second. If that upper-end estimate is real, we're not talking about a comet anymore. We're talking about an object the size of a small dwarf planet. It would be 1,000,000 times more massive than either Oumuamua or 2I Borisov. This would pose a fundamental problem for astrophysics. Our current models suggest there simply shouldn't be enough loose material drifting between the stars to build rogue objects that big. Either our size guess is way off, or we are missing something profound about how interstellar objects are formed and ejected from their home systems. All of these questions, the green glow, the nickel surplus, the sun-pointing tail, the potential supersize frame, are based on observations from telescopes here on Earth, looking through our own turbulent atmosphere. But in a few short weeks, we're going to get a completely new perspective. On October 3rd, 2025, the comet will skim past Mars. It will be close enough that NASA's Mars Reconnaissance Orbiter, or MRO, will attempt to take snapshots with its most powerful camera, HiRISE. MRO has been orbiting Mars since 2006, and its HiRISE instrument is the most powerful telescope ever sent to another planet, capable of resolving objects on the Martian surface as small as a coffee table. Now, the resolution on the comet will be much coarser, about 30 kilometers per pixel, because of the distance, but a simple picture isn't the main goal. HiRISE can also perform spectroscopy, analyzing the light from the comet to get a clean, unobstructed chemical fingerprint. This is our golden opportunity. By observing from Mars, we can see if the quirks are real or just artifacts of our Earth-based viewing angle. A Martian perspective will confirm if the anti-tail really points sunward, and crucially, a reading from above Mars's thin atmosphere will give us our cleanest data yet on its chemical composition. If the nickel-rich chemistry and strange gas ratios show up in those pictures, we'll know these anomalies are inherent to the object itself. So, what does it all mean? Right now, 3I Atlas still looks like a comet, just an extremely old, extremely battered one that's been soaking up bizarre chemistry in the vastness of interstellar space for perhaps billions of years. Each mystery, the emerald glow, the pure nickel, the forward-facing tail, and its colossal potential size, could be a clue, a piece of a puzzle that tells us about the star system it came from. Whether these clues add up to natural but bizarre or hint at something more is the question that has telescopes all over the world and soon around another world swiveled in its direction. What's your theory? Are we seeing exotic ice reactions from a star system with completely different chemistry? Or could it be something else, from alien geology to something even more speculative? Drop your ideas in the comments below. The best ones might just make it into the next update. And if you'd like to support the channel and keep these deep dives coming, picking up a t-shirt or hitting super thanks is a huge help. Thanks for watching. Stay curious, and I'll see you back here when the Mars flyby data roll in.